I'm on the Asus ROG Zenith 2 Extreme Alpha motherboard with beta BIOS 0081 and an engineering sample of the Ryzen Threadripper 5990X 64-core processor. I also have 32GB of DDR4 memory installed. The default CPU frequency is 2500 MHz, but we'll quickly sort that out to get more performance. I already made a profile for the 3DMark CPU profile benchmark, so let's load that up first. Then I'll show you the relevant settings before going to the benchmark. Firstly, I use DOCP to load the XMP settings from the memory sticks. This kit is rated at DDR4 4266CL19, but unfortunately that's too high of a frequency for this CPU. Usually I stick to DDR4 3600. I'm also running the Fabric in synchronous mode with the memory, so that's 1800 MHz for DDR4 3600 memory. Then the bulk of the tuning is done in the CPU core ratio submenu. Here we get access to the core VID and the CCX ratios. Ryzen CPUs have a single voltage rail for all CPU cores called VDD-CR-CPU. We can set the target voltage for that voltage rail using the core VID setting. In this case, I've set it to 1.45 volt. Now I know what you might be thinking, that's crazy for 64 cores. But 3DMark CPU profile is a really lightweight multi-threaded benchmark, so you'll see that it doesn't really matter that much. Then let's set the CPU ratio. Ryzen CPUs offer separate PLLs for every CCX. CCX stands for core complex and is essentially a group of CPU cores with their L1 and L2 cache and a shared L3 cache. For Zen 3, one CCX consists of 8 cores, whereas on Zen 2, one CCX only had 4 cores. The CCXs are integrated on the CCD or core complex die. That's basically the CPU die. On Zen 3, one CCD fits one CCX, whereas on Zen 2, one CCD had 2 CCXs. Ironically, Zen 2 Threadripper had more fine-tuning options as there were double the amount of CCXs. For Zen 3 Threadripper, we only have 8 CCXs to tune. To figure out the appropriate CCX ratios, I simply started from a 40x baseline for each CCX, then increased the ratios one by one to the highest stable setting. As you can see, there's a bit of a spread, with the worst CCX clocking in at 4625 MHz and the best CCX clocking in at 4825 MHz. I'll also show the VRM configuration, though frankly you can just leave that all at default. The motherboard auto rules do a pretty good job at configuring the VRM. Then, the last setting you want to ensure is set correctly is SMT mode. Make sure it's disabled so that only 64 threads are active. 3DMark CPU profile doesn't scale with many threads, so you want the threads to run on the real cores. Then hit F10 to save the settings. So now let's load up the operating system and benchmark. I'm running Windows 11 Enterprise as it may be slightly better at managing as many threads as the Ryzen Threadripper has. Click Start to run the benchmark. Overall, the benchmark takes about 14 to 15 seconds. It will automatically initiate the next test, but you can just press Escape to see the benchmark result of max threads. 32,807 points. Not bad considering the current published world record is only 27,418. We can run it again and see if we get a higher score.
Alright, 32,950 points. That's the highest I got so far, so I'll quickly save the result. Next, I'll open HWiNFO so you can also see the system temperatures and voltages during the benchmark. Let's ignore the benchmark score and check HWiNFO. As you can see, despite using 1.45 volt, the CPU temperature isn't near the TJ max of 95 degrees Celsius. The core clocks in at an average of almost 4.7 GHz, so that's pretty cool with 64 cores.
Maybe a quick note on the cooling solution.
I'm using the EK Quantum Momentum monoblock, a Coolstream PE360 radiator, and an EK Quantum Surface P480M radiator. It's definitely overkill for a quick benchmark like this, but much needed when running sustained workloads. For more information on that, I suggest you check out SkatterBencher number 43.
And that's it. I thank you for watching and the Patreons for the support, and see you next time.